Working already? Okay. Good afternoon, you too. It's a pleasure to speak with you. I've just a presentation on what we do is something very different from what we've seen so far, because at TRE we work in the field of deformation monitoring from satellites. In last year, we understood that our services has been used in the mining sector for several things. I mean, we discovered that surface displacement is affecting both the operational and the legal aspects of the life of a mine in various aspects. As you can see, you have here a brief list of the application that we found useful from what we do. I told you we use satellites to monitor the Earth deformation. This is a SketchUp of the acquisitions that we have, so we have a chance to acquire all over the world every more or less 6 days, so that more or less once a week. And we have no problem with acquiring, for example, when there is no sunshine, so that when it's nighttime and when there is a cloud coverage. With such data, what we do is, at the end of the day, to make a lot of processing, and these are the products that we have for you guys at the moment. I just want to throw your attention on the right-hand side, where you see the precision that we can get, so that we can detect displacement by means of centimeters, or we can scale up until the actual millimeters. We have we will have a chance to see these working. Actually, the base of the system is the fact that these phase satellites are radar satellites, so that they acquire images all over the Earth. We compare the phase of such images, and we create what we call interferograms. These interferograms speak themselves about the surface deformation. Usually, we provide the clients with maps like these ones, where red means usually subsidence or somehow movement away from the satellite, and green means stability. The mine you see here is not operated anymore in the pit, but they are doing some caving in this area here. And the red area that you see is subsidence, and it's triggering actually a landslide in the pit. So that from this map, they can understand what they are causing in the pit while working underground. Such maps are obtainable. I mean, we can do this every week. Just to give another example, very near here, this is Kiruna, and that's the map that we can get of the displacement of Kiruna more or less every week. In that case, it speaks about the subsidence in the production area, more or less about 6 centimeters. What we can do is to do something more, so that to stack up some imagery in time and to process a stack of images, not just a couple of images, and to come up to maps like this one. They are low resolution in terms of space, but we can measure meters. In that case, these red areas over there are moving 5 meters per year. And this map here help the people in Chile to understand that there's something undergoing over there, and it's better they do something to prevent some kind of collapse. Such data are intrinsically spread in time, so that we monitor motion in time. So whenever you want, you can trace a profile over the data and have this history of displacement in time. The best that we can do eventually is to stack more images in time, so that we can make some processing and get to the final millimeter. That's how we see to a mine site. Oh, I'm sorry. To a mine site, so that this is an area of more or less 20 by 20 kilometers. We are taking advantage of the fact that we are in space looking down, and we can see the compaction of the tailings, of the waste pile, of the movements in the pit, and all around the pit itself. Let's zoom in and see what it happens. This is the pit, and you see that there is some kind of heavy displacement in the area, and a part of this displacement is accelerating over here. So that for the geotechs, in that case, it has been quite important to understand that over here there is some sort of fault fixing some kind of movement. I don't know why it is moving like this, but it is moving like this, and for them it was pretty important to understand that it started moving sometime in the period where we've been observing the pit itself. So that such data are usually used in the pit to understand which is the situation without any kind of instrumentation, and to eventually set up a monitoring strategy with instruments to try to define and set up the proper alarm system. Such data are used all over the mine, so that with the same map we can see the movement around the tailings, so that we have the time series of displacement, and another time we can construct a profile of the displacement and see not just where it's deforming, but when it starts deforming, in order to correlate eventually to what you did over the place. Okay, so that you can track both a velocity of displacement and acceleration of displacement, whatever it takes. We are very sensitive somehow to vertical deformation. Another time, we look at the Earth from very high over there. There is no instrument on the market that is so sensitive to vertical deformation. That's what we see over the waste piles. Another time, zooming in another area from exactly the same map, you have an idea of the compaction that you have over the waste piles, and it can be used to plan a further development of these guys. And last but not least, we are very informative over infrastructure. In that case, the conveyor belts are affected by a differential movement, so that there's going to be somehow in the future a crack over the infrastructure, and with such data you have a way to know this before it happens, so that you can take a set of countermeasures against this fact to happen. Just to summary what I told you, we discovered that such technologies are very important when you need to plan a network of instrumentation for alerting the people, to remove the people in case of a landslide, for example. We are taking advantage of the fact that it's very easy to update, and we need really no instrumentation in the ground, so that wherever you have your operations in the world, we can operate this service with ease, and at the end of the day, it's going to be cheap. It's important usually for you guys. Thank you very much, you two, you three, you four. And this is my contact. We have a booth in the main area, in the entrance, so that if you want to stop by and have a chat, I'm free to answer all your questions. I have a question. Yeah. Thank you. I'm sorry. Okay. In the system, an eventual problem could be the snow coverage, not the frost itself. If we have things on the ground reflecting with respect to the satellite, we can eventually detect the melting of the frost. We did it, for example, in Norway. We did a project with them, and we've been able to measure, for example, some sort of glacial rebound still affecting the region after the glaciation. So that the technology is so sensitive to displacements that you can eventually track such small movements. The only constraint is the fact that we need something continuously reflecting towards the satellite, so that the problem for us is snow coverage and vegetation. Whenever there is a house and rocks, something exposed to the satellite, we can measure it. Okay? Thank you very much.